Imagine a network function that needs help from another. It sends a service request across the core, like walking up to a locked door and asking to come in. The service on the other side has a problem. Names alone are cheap. Anyone can claim to be a friend. So, what evidence would let the producer decide this request is actually allowed? The request needs more than a name, it needs a recognizable proof of permission, something temporary, checkable, and issued by someone the producer already trusts. That single question drives everything we are about to unpack. In fifth generation cores, many jobs are split into network functions that talk over a service based architecture, often shortened to SBA. The picture we are studying is a simplified view from Release 15. Instead of rigid point to point links, consumers discover and call producers as services. That flexibility is powerful, and it creates a trust problem. If any function can call any other, how does the system stop unauthorized access? The answer in this diagram is not a permanent password shared everywhere. It is a two-stage dance. First, get permission from an authority, then present that permission when you ask for the real service. Three roles make the whole story work. First, the NF consumer, labeled OAuth client. This is the function that wants something done. Second, the NRF, the network repository function, acting as the authorization server. Think of it as the desk that issues temporary passes. Third, the NF producer, written PNF, labeled resource server. That is the function that actually holds the service and must decide whether to answer. Keep these three fixed in your mind. The left half of the diagram is the consumer talking to the NRF. The right half is the same consumer talking to the producer. The token is the bridge between those two conversations. Stage one is the token request. Before anyone hands out a pass, the consumer and the NRF establish who they are talking to. The diagram calls this mutual authentication over TLS, or by an implicit method the deployment already trusts. Mutual means both sides check the other. The consumer is not shouting into the dark, and the NRF is not answering anonymous strangers. Only after that channel is trusted does the real authorization work begin. If you skip this step in your mental model, the later arrows look like magic. They are not. They ride on an authenticated session. Now the consumer sends a clear ask, request access token. That is only a request. The NRF does not rubber stamp it. Next comes authorize client. The server decides whether this consumer is allowed the scope it wants. Only then does the NRF grant access token. Watch the order: request, authorize, grant. Three distinct beats. The token that leaves the NRF is the temporary pass or doorway metaphor promised. It is not the service itself. It is evidence that an authority already said yes. Here is a misconception worth killing early. Students often collapse request and authorize into one idea, as if asking for a token were the same as being allowed one. The diagram refuses that shortcut. Request access token is the consumer speaking. Authorize client is the NRF deciding. Grant access token is the outcome when the decision is yes. The consumer does not simply declare permission. The authorization server decides whether to grant the token. That separation is the whole point of having an authorization server in the middle. Carry that granted token into stage 2, the service request. The consumer now faces the NF producer, the resource server. First comes authentication of the PNF, again over TLS or an implicit trust path. The consumer needs to know it is talking to the real service, not an imposter. Then, the consumer sends the service request with the access token attached. The pass travels with the ask. Visually, the token that left the NRF now appears on the arrow into the producer. That is the handoff the architecture depends on. The producer does not answer yet. The next step on the diagram is verify token. Only after verification comes the service response. So the token is not a magic open sesame. It is evidence the producer inspects. If verification fails, there is no happy path in this simplified view, and you should feel why that check sits before the response arrow. The token matters because the producer checks it before answering. Authentication of the channel and verification of the token are two different protections stacked in sequence. Another trap, thinking that mere possession of a token guarantees access. Possession is necessary in this story, but not sufficient. The producer still runs verify token. A stolen, expired, or wrong scoped token should fail that check, even though the diagram does not draw every failure case. So when you see service request with access token, do not skip ahead to service response in your head. Insert the verification beat. That habit will keep you honest when you read fuller protocol specs later. Look carefully at the two authentication labels. On the left, mutual authentication sits between the consumer and the NRF. On the right, the label is authentication of PNF, the producer. Both mention TLS or implicit, but they are not the same conversation. The first protects the channel where tokens are minted. The second protects the channel where the service is actually invoked. A student who merges them into one vague "they authenticate" misses why the diagram draws two separate lifeline pairs. Plain language, you prove who you are to the desk that issues passes, and you separately make sure the door you knock on is the real door. What kind of pass is this token exactly? The footnote on the diagram is precise. The token format is JSON, JavaScript Object Notation, Web Tokens, standardized as RFC 7519. People say JWT. JSON here means the token's contents are structured as data objects, not an opaque, random blob with no standard shape. Calling it a web token points at a widely deployed industry format, not a 5G only invention. So the pass is portable, structured, and named by a public standard the whole industry can implement the same way. Structure alone is not enough. Anyone could forge a JSON object that looks like a token. So the diagram adds the security layer. These tokens are secured by digital signatures or MACs, message authentication codes, based on JSON Web Signature RFC 7515. A signature or MAC lets the verifier check that the token was not rewritten in transit and that it came from a holder of the right keying material. We will not invent algorithms the slide does not name. The teaching point is simpler. The pass is both readable as JSON and integrity protected as a JWS. That is why verify token can mean something real at the producer. Put both halves on one timeline. The consumer and NRF mutually authenticate. The consumer requests an access token. The NRF authorizes the client and grants the token. Then the consumer authenticates the producer, sends a service request carrying that token. The producer verifies the token and only then returns a service response. Left diagram, then right diagram, one continuous loop. The token is the only object that moves from the authorization world into the resource world. Everything else is local to one conversation. Zoom out from 5G labels for a moment. What you just watched is a general pattern. Separate the act of authorization from the later resource request. An authorization server decides and mints evidence. A resource server checks that evidence when work is asked for. That is why the consumer is labeled OAuth client, the NRF authorization server, and the producer resource server. The SBA drawing is applying a familiar internet pattern inside the operator's service mesh. Once you see the pattern, the arrows stop being tribal 5G lore and become a reusable security story. Here's the whole argument in a few lines. In a Release 15 service-based architecture, an NF consumer does not simply demand a producer's service. It first authenticates with the NRF, requests a token, and receives one only after the client is authorized. It then authenticates the producer, presents the token with the service request, and waits while the producer verifies that token before answering. The pass is a JSON Web Token under RFC 7519. Protected with signatures or MACs via JSON Web Signature under RFC 7515. Broader idea, authorization evidence is minted in one place and checked in another. Open question for you. What else would a real service need to check before it could safely answer? beyond the token itself. Lifetime, scope, audience, revocation. The same careful reading of sequence diagrams will get you there.